It's algorithmic programming, that link right there. And this is the overview, breaking it into steps that was supposed to happen first. So an algorithm, in the basic terms, is just a set of steps used to solve a problem. So steps are directions. For computers, it can be solving 2 plus 2, or it can be as complicated as like your Google Home or your Alexa system, turning on all your lights and starting your coffee, or doing whatever you have to do when you wake up in the morning, or when you get home in the evening, as your car pulls in, having everything automate and do things that way. So the computers just follow a set of directions. And in Google Home, I know that they have a bunch of things. If you say I'm home, it will automatically run an entire list of steps, and that list of steps is processed in order. So if you change one of the steps before, it's going to happen before. So it's all about setting the program up to complete a task. And computers are dumb machines in the sense that they don't know how to do things unless they're programmed. And in order to program them, we have to have this algorithmic step, this step-by-step process. What happens when this happens? And then what happens after this step? So we're just going to walk through those steps one at a time. So if I have the example of brushing teeth, we would get out the proper materials, place the toothpaste on the toothbrush, brush each tooth for 2 minutes, clean toothbrush, rinse mouth, put away the materials. And so this is an algorithm. This is a step-by-step direction set that's going to get us from having the start of brushing our teeth to the ending of brushing our teeth. It's an entire process. So those are only some of the steps, and we could break them with decomposition. We could break them into a number of different steps for each one of these, like a set of instructions that would give us exactly what we have to do every single time. And for a computer, that's important because they need to understand exactly what's going to happen. If you tell a robot that it has to pick a box out of a bin or go from point A to point B, and you don't tell it exactly what it's going to do, it's going to go through stuff, hurt people, break materials, or not complete the task that you want it to complete. So we want to make sure that in algorithms, we're developing this set of instructions that's going to give our computer the ability to follow these directions in the right way. So other examples of algorithms that we use every day possibly, especially here in the fall: raking leaves, making a sandwich or making a peanut butter and jelly sandwich, opening a door, tying a shoe, sending a text, entering our classes, leaving our classes, getting up in the morning, going to bed at night. Those are all algorithms. They're just steps that we follow to get ready for whatever that task is. So I have a couple of directions here. There's a next file called 4x4s, and I'll explain that, and we'll look at how this process is going to work for giving directions to complete those tasks. And so we're going to edit the document and add some information there. So we're going to create an algorithm that's going to solve whatever this process is.